Now we're going to start this year off by doing matrices once again. And today we're going to talk about a thing called transition matrices. What a transition matrix applies is when you have probabilities. Now used to the idea of independent events from previous years. Toss a coin, the result of one coin toss does not affect the next coin toss. But sometimes you have situations where one probability affects the outcome of the next one. And we handle that with transition matrices. Now, transition matrices where the probability of one event depends upon the outcome of the previous event. Let's have a look at an example of that. Now, consider the stock market. So if you know that you've got shares, and if the stock market rises on a particular day, then you know that the very next day the probability of it rising is going to be 0.2. If it rises today, the probability of there being no change tomorrow would be 0.2. This is a made-up situation too, by the way. Don't go and base your investment strategies upon what I'm showing you. And if probability of event rises, if it rises today, the events of falling tomorrow is 0.6. Now, so this is if we know that if the stock market rises today, 0.2 chance of it rising tomorrow, 0.2 chance of no change tomorrow, 0.6 of a chance of it falling tomorrow. So this is rise today. But what if there is no change from today? Well, those probabilities in this scenario is 0.5 of a chance tomorrow that it's going to rise, 0.3 of a chance tomorrow that there once again will be no change, and then 0.2 of a chance tomorrow that there will be a fall. What if the stock market falls today? Well, then tomorrow they have a chance of rising of 0.7, no change of 0.1, and then falling again is 0.2. In this scenario, let's consider this particular situation. So what if we knew this to be the case? We can use this matrix to work out what the stock market may be doing tomorrow, 2 days, 10 days, even 20 days or more from now. As you can see here, we have a matrix set up, and we call this our transition matrix. And we use letter P to represent our transition matrix. So there's our transition matrix, which shows what's the likelihood of an event happening tomorrow, depending on what's happened today. So what if you have the question that says, look, you know that today, so we know that today the stock market rose. So what's the probability of the stock market falling 3 days from now? Can we work that out? Yes, we can. And this is how we set it up. Now, what I'm going to do is, this is our transition matrix. I'm going to set up another matrix called the state matrix. X is our state matrix, and X0 to indicate what's happening right now. So right now, today, we know that the stock market is rising. So a 100% chance today that it's rising, which means a 0 chance today that there's no change, 0 chance today that it's falling. That's our state matrix. We can now combine our state matrix with our transitional matrix to work out the state matrix for 3 days from now. Let me just give myself a little bit of room over here. So, in 3 days' time, what's going to be happening? So, X is our state matrix, and we want the state matrix for 3 days from now. How do we arrive at that? We take the state matrix for right now, and we multiply it by our transitional matrix. So if we just multiply it by transitional matrix, we'd have what the state would be tomorrow. If we multiplied it by the state matrix again, we'd have it for 2 days' time. Multiplied by the state matrix again, we would have it for 3 days' time. Clearly, it's a bit silly doing that when in fact we could just do this. We take what's happening right now, multiply it by the transitional matrix cubed, I'll have what's happening in 3 days' time. So if you were to go and put this into your calculator, and multiply them together, you'd get this result. This would be the result of taking what's happening today times by our transitional matrix cubed to give us what's happening in 3 days' time. So once again, the setup that we had before, this would be the probability of there being a rise in 3 days' time if we knew that it was rising today. This would be the probability of no change in 3 days' time if we knew that it was rising today. And this would be the probability of a fall in 3 days' time if we knew that it was a rise today. So of course, our question is, what's the probability of a fall in 3 days' time? So there. So a 0.424, about a 42% chance in 3 days' time the stock market's going to be falling. And that's what we call transitional matrices. We can continue this on for 2 days, 3 days, 10 days, 100 days, it doesn't really matter. So we set up a chain of events where one event then determines the next event, determines the next event. Now you might come across a word in your working called a Markov chain. If you ever see that, all that means is this situation where you're taking the state matrix for one particular day or one particular event and then applying a transitional matrix again, transitional matrix again. You have a chain being set up. The correct name is a Markov chain. It involves transitional matrices. So we'll have a bit of a practice on some of those questions.